Hello, this is Mrs. Ward, and I'm going to go over section 2.1 in chapter 2, which is about differentiation, and we're going to talk about the derivative and the tangent line. So most of what we're going to do today, we've done at points in chapter 1, but we just didn't really explain to you what we were doing. So today we're going to find the slope of a tangent line to a curve at a point. Then we're going to use the definition to find the derivative of a function, and then we're going to understand the relationship between differentiability and continuity. So let's begin with a formula that should look familiar. This came from chapter 1. This is finding the slope of a secant line. Remember, if I have C, f of C, that's this point here, and I take C and I add some number, delta x, then this will be, the height will be f of C plus delta x. And as I find the difference of y's over the difference of the x's, and remember that C plus delta x minus C will just give me that delta x. This was the slope of the secant line. So what we're going to do, and we've talked about this many times, is we're going to take that delta x, the difference between those 2 points, and we're going to move this point closer and closer and closer together so that delta x becomes smaller and smaller. And that's why we're saying this delta x approaches 0, is because we want that to be 0, and when it is 0, then we are actually finding the slope of a tangent line. We'll find the slope of the tangent line at that given point. I just want to point out that most of the time, the slope of a tangent line is different for different points. So so we're going to do this two ways. One, we're going to find it at a specific point, and then we're going to later have formula to find the derivative at any given point. So this is to find the slope of the tangent line or the derivative at a specific point. So I'm only looking at one point on my graph. So this is saying that I'm going to take the limit as delta x approaches 0. The change in y, the change of x just means that I'm finding the slope. And this is the calculations that I would have to do to find the slope. I'm going to take f of c plus delta x minus f of c, and I'm going to divide it by delta x, or the change in x. And then I want to have that delta x approach 0. Remember, the delta x's should simplify. And then now that will be the slope of the tangent line at that specific point C. So, and that's all this is saying, is that you're finding the slope of the tangent line at that point. So let's start off with the baby one. So find the slope of the graph of f of x is equal to 3x minus 7, and they give me the 0.45. So where I got that 0.45, if I put 4 into this equation, I do get 5. So that's where that point comes from. So I'm going back and I'm using this formula here, and I'm going to substitute what I have. So I'm going to take the limit as delta x approaches 0 of f of c plus delta x minus f of c all over delta x. So just to be clear, in this case, my c is going to be the 4, and f of c is going to be the 5. So when I substitute in, I'm going to take the limit of delta x as delta x approaches 0 of, I'm going to have 4 plus delta x. I'm going to multiply that by 3, so that's 3x minus 7 minus f of c, which is 5, and this is all over delta x. And this is a pretty key step, taking the limit as delta x approaches 0. So I'm going to write that every single time. So when I distribute my 3, I'm going to have 12 plus 3 delta x minus 12 all over delta x. And what I'm going to notice is that the 12 plus the negative 12 will equal 0. And the delta x divided by the delta x will be 1. So I'm going to take the limit as delta x approaches 0 of 3. And I have no place to substitute that delta x in. So that means my slope is going to be 3. So the slope of the tangent line at x is equal to, and remember our x coordinate was 4, at x is equal to 4 is 3. Now, if we take a step away from this problem for a second, let's go up here and talk about this. 3x minus 7, well, that's a linear function, and this will happen with linear functions. This is a linear function. If I were to graph it, I'm going to have y-intercept of -7. I'm going to have a slope of 3, so my graph is going to do something like that. It really doesn't matter what point along this line I pick. My slope is always going to be 3 because the slope of the line is 3, so the slope of the tangent line is 3. So that one, if you don't end up with that coefficient, and it's a linear function, then you know you made a mistake. But that's what I consider a baby one. So we're going to find the slope of the tangent lines of the graph. F of x is equal to x squared plus 4. And we're going to find it at 2 points. One point's going to be 0, 4, and the other point's going to be 2, 8. So it's no longer a linear function. It's a parabola. If you wanted to sketch the graph, you could. You know it's going to be a parabola. Does something like that. So the slope at 0, when x is equal to 0, is the slope of the tangent line is going to be something like this. And the slope of 2 is going to be something like this. So I'm going to have two completely different slopes when I do my calculations. So I am going to substitute in the 2 points. So let's do this one first. So I'm going to say the limit as delta x approaches 0. And the first one is going to be c, which is 0, plus delta x squared plus 4 minus f of c, which is 4. And this is going to all be over delta x. I'm taking the limit as delta x approaches 0. This is just going to be delta x squared. And then 4 plus -4 will be 0. And this is all over delta x. One of those delta x's will simplify. And I am going to be left with the limit as delta x approaches 0 of just delta x. Substituting, it's okay to substitute in 0 for delta x. Substituting 0, I get 0. So the slope of the tangent line at x is equal to 0 is 0. And based on my drawing, it kind of looks like that would be right. Now let's do the next one. I'm going to take the limit as delta x approaches 0 of, it's going to be 2 plus delta x squared plus 4 minus f of c, which, remember, this is my f of c, so that's going to be 8. And this is all over delta x. Remember, this is c plus delta x, so the c is 2. So now when I square this, and squaring it properly, I'm going to have 4 plus 4 delta x plus delta x squared, and then the plus 4 minus 8 will be minus 4 all over delta x. The 4 plus the -4 will be 0. Everything that I'm left with in the numerator will, delta x will factor out. So I'm going to factor out delta x from that 4 delta x and from the delta x squared. All over delta x. The delta x's will simplify. And now I'm going to take the limit as delta x approaches 0 of 4 plus delta x. Okay for me to substitute in, so this will be 4 plus 0, which will be 4. So the slope of the tangent line at x is equal to 4, I believe. Oh, x is equal to 2. Glad I checked that. X is equal to is 4. So two different slopes at different points. And every point on that graph will have a different tangent slope. So that's why you'd have to do it at each point. Now, if I wanted to talk about this change, like what's happening with this graph, I'm not going to want to do like, I'm not going to want to find the slope at 0, then find the slope at 2, and then find the slope at 4, 6, 8, or whatever. I'm going to want to have to do a formula. So we're going to talk about that formula in a second, but I just want to mention this. Sometimes what's going to happen is if I go to find the tangent line and I'm going to do like side limits for my tangent, and I'm going to say what's going to happen as delta x approaches 0, sometimes it may equal infinity, sometimes it may equal negative infinity. And if that happens, if you get this tangent line slope to be infinity or negative infinity, that means you're going to have a vertical tangent line. And that means you cannot find the slope because it's a vertical line, and the slope of the vertical line is undefined because I have a change in y, but I don't have a change in x, so I'm trying to divide by 0. So look out for those vertical tangent lines. So this is what I was talking about before. This is when I want to find a formula to find the slope of the tangent line at any given point. So when I'm when I want to find the slope of the tangent line at multiple points, I'm going to use this. And this is also called the definition of a derivative. And this is also finding the derivative using the limit definition. So when we do this, we are trying to find the derivative. Derivative means the instantaneous rate of change at a given point. So this is the formula. It's the same formula we've been doing. Before we just put C and C in here. We're just going to leave the x's in here. This is just like those problems in chapter 1 that we were doing where, you know, I told you it was my favorite problem. That's why this is my favorite problem. Now, I also told you that this is the derivative, and there's different ways. You'll see this little tick mark. That stands for derivative. Different ways of writing derivative. dy dx, that's a change in y with respect to the change of x, which is the slope. Y with the tick mark means y prime is also read like that. Then you can do d of f of x, that's another way, or dx with the y. Hardly ever use this one, hardly ever use this one. These become very popular. This one is hugely popular when we start talking about related rates, so we'll keep that in mind. So let's move on. So here, when I read this, I'm going to say I'm going to find the derivative of y with respect to x. In other words, I'm finding the change in y with respect to my x. And these are all the different ways that I can write it. So I am going to find the derivative of f of x as 3x squared minus 5. So I'm using that formula. You will have to memorize that formula. I told you I'd give it to you in chapter 1. I'm done giving it to you. So the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. So when I do this, I'm going to put in x plus delta x every place I see an x. So still taking the limit of delta x approaches 0. And we've done these quite a few times. So this one, so I'm going to do 3x plus delta x squared minus 5 times x plus delta x minus f of x. And f of x will be that 3x squared minus 5x. You're probably going to want to put that in parentheses so you remember to distribute that negative sign. So now I'm taking the limit of delta x approaches 0. I am going to FOIL this plus 2x delta x plus delta x squared, distributing my negative 5, distributing the negative sign. Now I have to distribute that 3. If I'm having a good day, everything over here that does not have a delta x should simplify. Everything that's left has a delta x. So I'm going to factor out a delta x. Remember, the key point of this is what's changing it from a secant line to a tangent line, and then eventually the derivative is taking this limit as delta x approaches 0. That's the key part of this problem. So you got to write it. So I'm factoring out delta x. Over delta x. Here the delta x's will simplify, which is great because now I can do direct substitution and I can put this 0 in any place I see a delta x. And when I do that, I am going to be left with 6x minus 5. I'm going to go back up here and check my notation. This was given to me in f of x, so I am going to write this as f prime of x is equal to 6x minus 5. So this is the formula for the derivative of this function. So if I wanted to find the derivative at, let's say, x is equal to 0, so that would be the ordered pair 0, 0. So at that point 0, 0, all I have to do is do the derivative at 0, minus 5, and then that derivative at 0 is going to be negative 5. If I wanted to find the derivative at 1, so x is equal to 1, that ordered pair would be 3 times 1 squared minus 5. Negative 2, I think. It doesn't really matter. I just need the x value. So if I wanted to find the derivative at 1, I'm going to take 6 times 1 minus 5, and that's going to be 1. So that's how I use the derivative. That's how I find the derivative. And I just made these up. These are not on your note sheet. I just got them out of my brain. There they were. All right, so it wants me to find the derivative for f of x is equal to x squared, and then find the slope of the graph of f at the points 1, 1, and 4, 16. So that's just what I did. So I'm going to do the limits as delta x approaches 0. Can I skip right to it? Sure. I'm going to do x plus delta x squared minus f of x, which was x squared, all over delta x. I'm going to take the limit as delta x approaches 0. I'm going to square that, so there'll be x squared plus 2x delta x plus delta x squared. Then the x squared and negative x squared will equal 0. Everything I have left will have a delta x be able to factor out of it. So that delta x will simplify. Now it's okay for me to put 0 in for delta x. So I'm going to have 2x plus 0. So this is going to be 2x. Going up here to check my notation, f of x is telling me I'm looking for the derivative. So I'm going to write that like that. Now it wants me to find the derivative at the point 1, 1. So at the point 1, 1, I'm going to do the derivative at 1, which will be 2 times 1, which will be 2. The other point they give me is 4, 16. So I'm going to do derivative at 4. So 2 times 4, and that derivative is going to be 8. So I'm going to find the derivative with respect to t for the function y is equal to 2 over t. So I'm just going to write it like this for a second so I don't get confused. So I am going to take the limit as delta t approaches 0, because I'm not dealing with x anymore. I'm dealing with delta t. I'm going to scooch this guy out of the way. So I'm going to do 2 over t plus delta t minus 2 over t. That's that f of x plus delta x, but now it's t plus delta t, all over delta t. In order to add these, remember we talked about these before, I have to have a common denominator. My common denominator is going to be t times t plus delta t, which means I'm going to have to multiply this fraction by t over t. So that'll be 2t. And this fraction, I'm going to have to multiply by t plus delta t. So I'm distributing a negative 2, so that'll be minus 2t minus 2 delta t. And this whole thing is still over delta t. So I'm going to take the limit as delta t approaches 0. Here, the 2's will 2t's will equal 0. And I am going to be left with negative 2 delta t over t times t plus delta t. and this delta t is understood to be over 1, so I'm going to multiply by the reciprocal, so 1 over delta t. The delta t's will simplify, so I'm still taking the limit as delta t approaches 0. Now that I've eliminated that 0 in the denominator, I should be able to do direct substitution. So I'm going to have negative 2 over t times t plus, in place of that delta t, I'm writing 0. So I'm going to have negative 2 over t squared. And that's my limit. I'm going up here looking at that they had a y. So for the show my notation that I found the derivative, I'm going to do y prime. And then again, if I wanted to find the derivative at a certain point, I'm just going to substitute whatever that t value is for the t. Okay, differentiability and continuity. So I can now find the slope of a tangent line, and as if I'm trying to find this slope of the tangent line, if I have approaching a number from the left or from the right, as long as it's equal to the same number, then I'm going to have a derivative. If it's not equal to the same number, so the slope is different approaching that c value from the left than it is approaching it from the right, then I'm not going to have a derivative. So the main one that this usually happens with is an absolute value. So here I have an absolute value. Remember, all this is saying is the slope, and this is finding the slope at 3. So this is doing all the work for finding the slope at 3. So if I bring out my graph, here's 3. If I'm approaching 3 from the left, remember this is from the left, and I look at this graph, I'm approaching 3 from the left. Well, the whole time this slope is going down, and it's going to be a negative 1. So this slope is going to be a negative 1 approaching from the left. If I'm approaching from the right, so I'm coming from the right, coming this way, well, now my line is going up, which means my slope is positive. So this slope is going to be a positive 1. So since these two do not match, I do not have a derivative at 3. So I have no at x is equal to 3. I have a derivative everywhere else. Anything less than negative, or sorry, anything less than positive 3, the derivative is negative 1. Anything greater than 3, the derivative is positive 1. It's just at the point 3, I don't have a derivative at all. So this is an example of what we call a sharp turn, which means that the slope changes dramatically at a point. So in this one, I'm going from negative 1 to 1, like in an instant. So I do not have a derivative x is equal to x is equal to 3. This is still a continuous function, though. There's no discontinuity to this function. This function, if I look at it, is perfectly good. If I go to my table, it's going to say it's going to be values for every single number. So it is a continuous function. It just happens to have one point where it doesn't have a derivative. So let's talk about another one. So I have this graph here of f of x is equal to x to the 1/4. So if I want to find the slope of the tangent line at 0, and I'm going to do that work that we did before. I'm going to do f of, still taking the limit as x approaches 0. F of x is x to the 1/4 power minus f of 0. Well, f of 0 is 0 raised to the 1/4 power, which will just be 0, all over x minus 0, which is x. So if I take the limit as x approaches 0, this is going to be x to the 1/4 over x. Well, I'm going to have to subtract my exponents. The larger one's in the denominator, so I'm going to keep the x in the denominator. I'm going to have 1 over x to the 3/4. Well, if I go to substitute 0 in, I'm going to have 1 over 0 to the 3/4. Well, that's undefined, which means I have no slope of a tangent line, which is going to be one of those cases that if you pick up your calculator and you were to graph that x to the 1/4, you get something that looks like this. Well, at 0, it looks like I have a vertical tangent line. Again, it's continuous at 0, but it just doesn't have a derivative. So that brings us to one important piece. If f is if I can find the derivative, then f is continuous. But it is possible to be the continuous without finding the derivative. So just something you need to know. And then lastly, this is the problems from the book that you're responsible for doing. And we will see you next time. Hope this helps.